Welcome to today's webcast, What's New for ALM in Visual Studio and TFS 2013. My name is Colin Dembowski and I'm an ALM MVP based in East London, South Africa. I work for a company called Imaginet, and I'll have more information on Imaginet's service offerings at the end of this presentation. My Twitter handle is @ColinDembowski and I blog regularly to colinsalmcorner.com. Before we start today's webcast, I'd like to tell you a little bit about Imaginet. We have over 650 successful ALM customers and over 1,800 successful ALM engagements. We're a Microsoft Gold certified partner with the ALM competency, and in 2011 we were Microsoft's ALM Partner of the Year. We have only the highest level of expertise with Microsoft ALM technologies and a close working relationship with Microsoft. On staff, we have multiple Microsoft Regional Directors, TFS Rangers, Virtual Technical Specialists, and many Microsoft MVPs. We're going to look at quite a few features that are new or enhanced in TFS and Visual Studio 2013. Here's a complete list of everything we'll see in today's session. This is the TFS 2013 Web Access page. If you've used the Web Access in TFS 2012, this will look very familiar to you, apart from a few color changes. In this version of Team Foundation Server, Agile Portfolio Management is possible. Let's look at a few changes to the backlog so we can see this functionality. I'm going to click View Backlog to open up the backlog for this particular team. This Fabricam Fiber team is the default team for the Fabricam Fiber project. Let's quickly look at how the teams are configured. If I look at the database team and select areas, you'll see that this team is constrained to see work items in the development area as well as the database team area. Of course, the devices team is similarly configured to see work items in the development and devices team area. This allows the teams to share the development area, but once work items have moved into their particular team areas, to work independently. Let's go back to the main backlog for the Fabricam Fiber team. This will show all the PBIs or product backlog items that are on the backlog. If we use this drop down here, we can go to the database team and we'll see that there's a smaller list of backlog items since these are the ones that are in the database team area. Again, this is very familiar functionality from 2012. What is different is you'll see that there's some color highlighting on the work item types. Here we can see that product backlog items have a blue highlight, while there's also a bug on our backlog that's colored in red. If you're using the on-premises version of TFS 2013, you can customize these colors. Another thing that's new is we can drill down into the task level right from the backlog view. On the top right, I'll expand this drop down here and select tasks. That's going to show me a hierarchy of how my product backlog items and bugs are broken down into tasks. We can also see past iterations by expanding the past iteration group node here on the left hand side. Let's click on iteration 2. Here we can see all the work that was done in iteration 2. If I click on the task burn down graph, I can see the burn down graph for that iteration as well. Of course, we can see the current iteration and continue to do work breakdown and capacity planning just like we did in 2012. We can also see future iterations and again do capacity planning and work breakdown for future iterations. TFS 2013 introduces the concept of backlog hierarchies. You'll see that there's a link called Features at the top of the backlogs list. I'm going to click on Features. That's going to show me a list of features that we've entered into this Team Foundation Server team project. There are 3 features at the moment. To see how these features break down into product backlog items, again we'll change the view to show backlog items. This is how we can see how the product backlog items are grouped into particular features. You can customize this hierarchy if you're using the on-premise TFS. You can add up to 5 hierarchies of backlogs. Let's go back to the backlog and add a new backlog item. Technician can check weather alerts. And we'll click Add to add that into the backlog. We can also drag that to an iteration to assign it into a particular iteration, and drag and drop to reorder and reprioritize this product backlog item. Let's parent this product backlog item to the feature. I'm going to click on Features, select the Technician Mobile Application feature, and make note of its ID. This is feature 210. I'm going to go back to the backlog items, and let's double click our new backlog item, and I'll move across to links. I'll link to an existing work item using the parent link type and type in the ID. We'll save and close that. Now when I go back up to features and turn on the product backlog items view, we'll see our new product backlog item listed. Of course, we can further break this down by changing the view to include tasks as well. TFS 2012 introduced test case management through the web access page. TFS 2013 builds on this, augmenting and enhancing the test case management in the web functionality. I'm going to click on the Test tab in the top to open up the Test Hub. You'll see the web page says that I can't create test cases without a plan. In TFS 2012, you couldn't create plans or suites from the web access. You had to do it through Microsoft Test Manager. In 2013, we can create those from the web. I'm going to click here to create the test plan, and we'll call this iteration 3. I can set the area path in the iteration or leave it as the defaults. Now I can create additional test plans, suites, or shared steps. I'm going to create a requirements-based suite that'll launch a query to query for requirements in my system. Let's run that query, and let's pick a requirement. The advantage of making requirements-based suites is that any test cases that we put into the suite are automatically linked to the requirement. We can either now click Add Existing to find existing test cases to bring into the suite, or we can click the New button to create a new test case. I'm going to click New to create a new test case. We'll call this Technician Can Create New Customer. If I scroll down a little bit, I can see the steps details. Here I can add new steps, shared steps, parameterized steps, or even step attachments. Let's add a few steps. To introduce parameters, just use an @ symbol and give a unique parameter name. Parameters can be used in actions or in expected results. If I scroll down below the steps, I'll see a table that has as columns the parameters that I've created. Let's create 2 iterations. Let's save and close that test case. Now that we have the test case in our suite, we could run this test case from Microsoft Test Manager, or indeed we could run it from the web access page. Running it from Microsoft Test Manager has the advantage that you'll be able to collect diagnostic data from the system under test. However, running test cases from the website has the advantage that there's no dependency on installed applications like Microsoft Test Manager, or even on operating system. As long as you can open a browser, you can run the test case. Let's execute this test case from the browser. Select the test and hit the Run button. Here we can follow the test steps. We can mark each step as passed or failed as we go. I'm just going to follow the test steps. Here you can see we have a parameterized step, and the step is telling us what values to use for the parameters. That test case looks successful. I'm going to hit the next to go to the next iteration of this test case. We can of course follow the same steps. Let's do so. Even though this page actually opened up, let's pretend that for some reason it didn't work. I'll mark this step as a failure, enter in a comment, and hit create bug to create a bug from this test case. If I expand this a little bit, you can see that the steps to reproduce field has been filled in and color coded just like it would have been out of Microsoft Test Manager. While there are no diagnostics because we were running this out of the web, it's still quite a lot of information. We can then see that the last test run failed for this particular test case. TFS 2013 further enhances team collaboration by using what are called team rooms. This is like a log of events that happen inside of TFS, mixed in with the ability to chat, that's all recorded at TFS level. On the home page here, if I scroll down, I can see that there's a Fabricam Fiber team room. I can also see how many team members are in the room. I'm going to click it to enter into the room. On the left hand side, on the Room Explorer, I can see all the rooms I have access to. If I have permissions to, I can create new rooms as well as configure rooms. Here you can see some chats that have taken place in the past. Using the @ symbol, you can easily tag a team member to get their attention. If I scroll up a bit, we'll see there are work item change events colored in blue. Clicking on the link will open up the test case in the web access view so that I can see that test case or that work item. Purple events are change sets. Again, clicking on the link will open up the change set so that I can see the details. Let's configure this team room to get build notifications for a particular build that we've just set up. I'm going to expand Manage Events, select the build completion events, and allow the build by anyone to pass events through to this particular team room. We'll save and close that. I'm going to queue a new build. There we can see there's a new notification for the build. Again, if I click that link, it'll open up the build detail inside of the web access. I've opened up Visual Studio 2013, and here you can see the new improved Team Explorer. It's been redesigned, and you can see some color has been added back into Visual Studio. We can also see that once I've set up a workspace for my source control, that I can see a list of solutions that I have under source control. I'm going to double click this Fabricam Fiber Call Center solution in the demo main folder. I'm going to debug this application. I'm going to click on the employees link to go to the employees page. I'm going to press delete on the last employee record, James Kernard. There's a confirmation page asking me if I'm sure I want to delete this employee. I am, so I'm going to press delete. However, when I come back to the employee list, I can still see that record. There seems to be a bug in the application. Let's close the application and go back to Visual Studio. The first thing I'm going to check is the data access layer. Let's open up the data access methods and go to the employee repository. I'm going to scroll down a little bit till I get to the delete method. I'll set a breakpoint on the delete method and we'll rerun the application. Again, we'll click employees, click delete, and click the delete button to confirm. The breakpoint is hit, so we're definitely getting into the delete method. However, there might be a complicated call stack. With Visual Studio 2013 code maps, I can visualize the complex relationships in my code. I'm going to right click on the highlighted line and select Show Call Stack on Code Map. Visual Studio draws the call stack for me on this designer surface. We can see that from the delete confirmed method, we got into the delete method of the repository. Let's stop debugging there. We can further augment this diagram. I'm going to double click the delete confirmed, and that'll take me to its definition in the code. If I right click delete confirmed, I'm then going to select show related items on code map, show methods this calls. That's added a few nodes into the diagram for me. I'm going to scroll up a bit to the edit method, and again I'm going to show related items on code map, show methods this calls. That'll add in all the code that the edit method is calling, and we'll do the same for the create method. We can see there's several calls to this externals. I'm going to expand the externals, and we'll see that the delete confirmed, edit, and create methods all call this redirect to action. So I'll right click redirect to action, select advanced, group, and remove from parent. Then we can delete the rest of the externals since they're mainly properties that we're not really interested in. Let's remove this reference to the employee repository delete method, since we know that the concrete method is in the employee repository class, which you've already got on the diagram. Let's change the layout to be a left to right layout. And again, we'll delete this external code. Let's move these nodes around a little bit so we can see what's going on. We can see that before calling redirect to action, both the create and the edit methods call the save method. However, we can see that the delete confirmed method doesn't call the save. Let's add a note on delete confirmed here. I'm going to right click and select new comment, and I'll type in shouldn't this call save. We can now share this diagram by using the share drop-down, and we could select email as an image. That'll allow me to email a team member with this particular diagram. We can also save this diagram for later use by going to File and Save Call Stack DGML. Let's go back to the controller method and add the call to save in the delete method. Let's build the solution and then right click delete confirmed, and again show methods this calls to refresh the map. We can now see that delete confirmed has got a call through to save as well. Let's rerun the application to check that our bug fix worked. Click employees, click delete, confirm, and we can see that the delete method has been fixed. By using CodeMap, we were able to visually understand relationships in our code and quickly find problems. Code lens, also known as code information indicators, are a new feature to Visual Studio 2013. They give us a heads-up display with some information about methods within our code. You can see this as an extra line above each method within the code. Here I can see that this method has one reference. Clicking on the link opens up the reference. If I mouse over the reference, I get some context, so I see the line before and after the reference. Double-clicking will take me to the source of that reference. Let's go back to the index method we were looking at. I see the test case indicator saying that there's one unit test for this particular method. 0 out of 1 are passing, since we haven't run any of the tests yet. Again, clicking on the link will give me more detail. I can see that this method is tested in the getWeatherForWeek unit test. Let's hit run all to go and run that test. We can now see that the indicator changes to 1 out of 1 passing. Again, if we double click, we'll get to the test case. Here in the code lens for the test case, we get an indicator indicating what the current result of the test case is. Let's open up another not run test. Here we'll see these tests have the indicator of not yet run, so we can see immediately which test cases have and haven't been run. Let's go back to Weather Controller. The next bit of information is the author of this file. We can see that Adam Barr authored this file. If we click that or click the changes indicator on the right, we'll see all the changes for this particular file in source control. If we mouse over that, we get a little bit more information on who checked in the change set and what the date of the change set was. If we right click, we can select View Diff. That'll launch the diff window to show us what code changed for that particular check-in. You can configure the code information indicators by going to the Quick Launch menu, typing info, and clicking on the Text Editor All Languages Code Information Indicator setting. Here you can turn on or off code information indicators according to your preferences. One of the advantages of managed code is that you don't have to clear memory yourself. However, sometimes if you have leftover references to objects, the garbage collector is unable to clear those objects. The symptom of this is often what we refer to as memory leaks. These are hard to diagnose, but with Visual Studio 2013's new memory diagnostic tools, we can more easily diagnose memory issues. I have a pretty vanilla MVC application open here with just a few code changes to illustrate this principle. Let's run the application without debugging in IIS Express. Let's open up the performance monitor. I'm going to click on Performance Monitor, remove the processor time counter, and let's add a heap counter. I'll browse to .NET-CLR memory, select the bytes and heaps counter, and then select the IIS Express instance. This is an indication of how many objects there are in memory. I can see that at the moment I have around 11 megs in memory. Let's refresh this home page 10 times. If I now open up the performance monitor, we can see that our memory is increased to 19 megabytes. This is a good indication that we've got a memory leak somewhere. Let's start the application again so we get a clean start. Here we can see our memory is at around 6 megabytes. I'm going to take a memory dump. There are many ways that you can do this. I use a tool called procdump from sysinternals. I'll tell procdump to make a dump of the IIS Express heap and dump it to dump1.dmp. Now again I'll go back to my web page and refresh 10 times. Again, looking at Performance Monitor, we can see that the memory is increased. Let's take a second dump. Now let's open up the second dump file. I'm going to say File, Open File, and browse to dump2.dmp. Visual Studio opens up the dump file, and I can see some information like what modules there are. I can see that the IIS Express is in here. I'm going to come across to the Debug Manage Memory link and click it so that Visual Studio can analyze the heap. If I look at this, I can see most of my memory is held in byte arrays. If I expand those, looking down at the reference graph, I can see that the byte array is referenced from inside the models.user object, which in turn is referenced from the user array, which is inside the reference to a list of sample leak model users. That in turn goes to system object, which has pinned handle next to it. A pinned handle is some reference, like a static variable, that cannot be garbage collected. This seems to be the reason why my memory is not getting garbage collected. It also seems a bit strange to me that my user objects are so large. Let's now have a look at how we can compare this dump to a baseline. I'm going to select the drop down, hit Browse, and open up the dump1.dmp. That's going to analyze the difference between the two memory dumps. Here I can see that the byte array difference is 10, corresponding to the 10 page clicks that we had. So it's safe to say that each time we click on the page, we get a new array of bytes. At this point, a little application knowledge is required. I know that on the home page, we're accessing the user repository to check some data on the user. Let's again click on one of the instances, and we can see that we have a list of users somewhere. Let's do a quick search for list of user. That's brought me to my user repository. The first thing I can see is that there's a user cache here. However, the getUser method adds to the cache, but never actually reads from the cache before adding. This is probably the source of the expanding list of user objects. Let's also see what references the getUser method. Here's the index method of the home controller. We don't seem to be using much of the user object at this point in time. Let's go and have a look closer at the user object. The user object has a binary data property, which is a byte array. This is the source of the byte array objects on the heap. Since we don't need it at this stage, perhaps we can be a little bit more selective in what we're getting for the user object from the database. Let's go and fix those issues. Instead of select star, I'll select ID and username so that we don't get the binary data back. Secondly, I'll add the code that will check the cache before we simply add the user to the cache. I've added a bit of code to check the cache to see if the user is in the cache before we actually access the database. Let's again start the application without debugging to see if our changes have improved the memory usage. Our memory is sitting at around about 7 megs. Let's take a memory dump here to set a baseline. Let's again refresh 10 times. If we look at our performance monitor, we can see we've gone up a little bit, as we should expect, but we haven't gone up as much as we did before we made the fixes to our code. Let's take another memory dump, just so that we can verify the fix. Again, I'll close the application and open up the dumps in Visual Studio. Again, I'll click Debug Manage Memory to analyze the second heap. And here we can see that system byte is no longer at the top of the list for the most objects in memory. That's already a good indication. Let's now again browse to dump 3, the baseline for our second run, so that Visual Studio can do the comparison. Let's do a search for user, and here we can see that the difference in count is 0 between our first hit and our 11th hit. By analyzing the heaps, we've been able to fix a memory leak. TF Service, or Team Foundation Server in the cloud, introduced Git repositories. In TFS 2013, you get the ability to create Git repositories for your team projects with the on-premise version of Team Foundation Server. Here in the new team project creation wizard, on the Specify Source Control Settings page, I have two choices. Either I can use Team Foundation Server Version Control, or TFVC, or Git as my backend version control system. I've already created a project called Agile Git that's configured to use Git as the backend source control repository. Let's connect to the Agile Git project. I'll click the Connect to Team Projects button in the Team Explorer, and that'll show me the team projects that I have access to. The Fabricam Fiber is a TFVC project, and it has a Visual Studio icon, while the Agile Git uses Git and has a Git icon. I'm going to double-click Agile Git to connect to it. A yellow information bar pops up at the top of Team Explorer to allow me to clone this repository. I'm going to click Clone. The clone repository function defaults the address for this Git repository. That's the URL that I'm seeing at the top. I'd be able to give this to any Git client and allow them to clone this repository. It's important to note that Team Foundation Server's implementation of Git is just that. It's Git. It'll work with any Git client. The second part is to specify what folder I'm going to map that into. I'm going to change the folder slightly. And click Clone. That'll clone the repository for me. In the Solutions section here, I can see that I'm on the master branch, and there's no solutions on that particular branch. I'll click New to create a new project. To keep things simple, I'm just going to create a Windows console application. We'll put it inside the folder we cloned for the repository. Let's click on Changes. Before we can do any commits, we're going to have to make sure we configure our username and email. I'm going to hit Configure to bring up the configuration. I'm going to enter in an email address for Adam and hit Update. Let's go back to Settings again by clicking on Home and Settings, and then Git Settings. Here you can see under Repository Settings, I have no default ignore and attributes files. I'm going to click the Add link to go and add those files in. Those will help me with default attributes and default ignore specifications. Let's again go back to our changes. We can of course commit from within Visual Studio, so let's do that now. Initial import is my message, and I'll hit commit. The commit and its hash come back in the Team Explorer window. If I click that, I'll get details of that commit. Let's make a change to this file. We've added some code in. I'm going to open up a PowerShell session. Let's change to the directory where we have our changes. we can see that there's an untracked change in this directory. Let's add it into the track changes by using git add. We can also commit this. I want to make sure that I do the commit against a work item. Let's go back into Visual Studio. I'll click on the home page for Team Explorer, open up work items, and double click the My Tasks query. I can see that I've been assigned task 247. Let's associate this commit with that task from the command line. On the command line, I'll type git commit -m to give it a message, adding console write line, and then I'll use #247 to associate this with task 247. We can see that one file has been changed. Let's go back into Visual Studio. Of course, if I go to changes, there are no changes since we've committed everything from the command line. Let's double click the task and go to all links. You'll see that the link hasn't yet been created. The link between commits and work items happens as an asynchronous job, so it'll take a few moments to process before the link appears. While we wait for that to update, let's push the changes from our local Git repository up onto the TFS server. From the point that we cloned the repository, we could have been working completely offline and disconnected from TFS. Of course, to push our changes to TFS, we need to be connected. I'm going to click Home, select Commits, and this will show the list of commits that are outgoing. I'm going to hit Push to push those commits up to the server. Team Explorer tells us that we successfully pushed 2 commits to Origin Master. Let's create a local branch. I'll select the Master Branch drop-down, select New Branch. Let's enter the name Dev, leave Checkout Branch selected, and click Create Branch. That'll create a new Dev branch for us. You can see which branch you're on by seeing which branch is written in bold text. Let's go to program.cs and make a change in the Dev branch. We'll go to Changes, and let's commit this. I'll type in Changed in Dev and hit Commit. That'll commit that change into Dev. We can easily switch branches simply by going to the Branches page and selecting the branch from the drop-down. If I switch to Master, I get the Master branch. Switching back to Dev will show me what's in the Dev branch. Let's switch back to Master and make a change in Master. Again, we'll commit that change by going to the Changes pane. I'm now going to select the branches and we'll merge. Here we can choose the source and target branches that we're going to merge. Let's merge from Dev to Master. I'll hit the Merge button. Most times the merges will work automatically, but every now and then you'll get a merge conflict. I'm going to select Resolve Conflicts so that I can see the conflicts. I'd be able to do this from the command line as well, or any other Git client that I use. I'm going to click on program.cs where the conflict is and hit the Merge button. This will show me the source and the target branches, as well as the merged result in the bottom. I like both changes, so I'm going to select both of them. We can of course edit if we need to. Let's make an edit to the merge. And when we're happy, we'll select Accept Merge. We can now commit the merge by selecting Commit Merge in the Team Explorer pane. The comment's been auto-filled out for us, Merge Branch Dev, which is fine. I'll hit Commit. We've now committed the merge in. While we've been working on our code, Brian's also made some changes which he's committed to the repository. I'm going to go to commits. Before we push our changes, let's make sure there are no incoming commits. I'm going to click fetch. Looks like we do have a commit incoming. It seems like Brian has made some changes to the code. If we double click the change, we can view his commit. We can right click and select compare with previous to see what changes he pushed up to the repository. Looks like he's also changed the console message. Let's do a pull to take those changes. Of course that results in a conflict, so we'll resolve the conflict. And again, we'll use the merge tool to merge. Once we're happy with the merge, we accept the merge, and then we can commit the merge. We'll select commit. Let's go back to our commits and push our changes up. Brian would now be able to access the changes we've made on our local repository. Let's have a look at what we can see in the web access site. I'm going to click on code. That'll open up the Code Explorer in web access. Here I can see my code. I can also see my history and see all the commits that have come into this repository. I'm going to click on the adding CW247, and here we can see that this commit has been associated with the work item. If I click on the link, it'll open up the work item, and now under all links I can see the link from the work item to the commit. We can also add comments using the lightweight comments function in web access. Finally, we can actually create multiple Git repositories in a team project. To do this, go back to the Explorer, and from the top menu here, we'll select Manage Repositories. From here we can create new repositories. We can also set access control and security on each repository. Tracking releases across environments is a complex operation. Automating those releases adds further complexity. Visual Studio 2013 introduces InRelease. InRelease is a product that Microsoft purchased from InCycle. It's now going to become part of the Team Foundation Server product suite. InRelease allows you to track and automate deployments across environments. There are a couple of components to the InRelease architecture. This web page is the web client and can be used to do approvals for deployments. Here's a previous deployment. If I click on this component button, I can see that the call center site was deployed. I can see which build number was used for the deployment. I can see that the deployment got all the way to the production environment. If we click one back and go to the previous stage, we can see all the actions that occurred in the QA environment. Let's go to the InRelease client. The InRelease client is a WPF application which allows us to configure InRelease. We can track releases and approval requests. We can configure our applications that we're going to deploy. We can configure our paths, showing how an application is deployed across multiple environments and how that application flows from environment to environment. We can specify our inventory of actions and tools. These are the building blocks for automating deployments into our environments. And finally, we can administer pick lists, groups, users, and our connection to TFS through this console. So let's see how we can track a build through the deployment pipeline. I'm going to open up Visual Studio. We'll connect to the Fabricam Fiber project, and I'll go to the Source Control Explorer, and I'm going to open up the Fabricam Fiber Call Center solution from the main folder. I'm going to open up the layout view, and we'll change this heading 2 from support to support v2.0. Let's check that change in. We now have a change that we'd like to deploy to our various environments. In Release uses services called deployers to deploy to various environments. For this demonstration, I'm going to use the same machine but different virtual directories in IIS to simulate the different environments. Let's browse the dev Fabricam Fiber website. We can see that the layout says Fabricam Fiber support. We want to deploy our changes that say support v2 out into the dev environment. Let's go back into Visual Studio and look at our builds. I'm going to right-click the Nightly Fabricam Fiber build and select Edit Build Definition. If I come down to Process, we can see that we're using the in-release default template. This adds a few in-release specific functions to the default template. The important one here is that released build is set to true. Let's queue this build. The build is completed. Let's go and check the in-release console. I'm going to click Track Releases, and here we can see that traffic has increased from 1 to 2 in the dev environment. I'll double click that to open up. Here we can see that we've got a second release. It's now sitting at the current step, Approve Release. If we double click on that, we'll get a log, and we'll see that Brian Keller has got a pending approval. Let's run the in-release web client as Brian. Here we can see that Brian has a release. If Brian clicks on the components, he can see the call center site and the build number that's been deployed. You can see that it's been deployed to the dev environment, and clicking on that will show him the steps that have occurred up until this point. Let's go and check the Fabricam Fiber dev site to make sure it deployed successfully. I'm going to open up a new tab and click on Fabricam Fiber dev. We can see that the page now says support v2.0, so our deployment to the dev environment was successful. Let's go and approve this to move it on to the next stage. Or enter a comment, dev looks good, and hit approve. Let's go back to in-release. We'll see that the QA traffic has increased to 2. Let's go and check the current status of this release. Here we can see it's moved from dev into QA. It's now sitting with the QA team pending an approval. Brian's also part of the QA team, so if we go back to the in-release approvals page, we'll see that there's now a second approval. Let's go and check that the QA deployment succeeded. We've refreshed the QA site and we can see that it says support v2. Let's go and approve the release. I'm going to hit approve, enter in QA looks good, and hit approve. Immediately we get another approval. For production, we've set up the acceptance step to be manual. For both dev and QA, the deployment path did an automated acceptance for the deployment. For our production, we want to make sure that the ops team is ready. Before any deployment takes place, we're going to have to accept the deployment. We'll go ahead and accept the deployment. We'll type in go ahead. You can see we can actually specify a deferred deployment if we don't want to deploy now. I'll just leave it empty to deploy now, and we'll hit approve. That'll trigger the automated deployment to deploy into the production environment. We'll go back to in release to track the deployment. We can now see that the deployment is in the production stage. Let's go and check that the deployment succeeded in the production environment. We see support v2 in our production environment, so it looks like the deployment worked successfully. Let's go back to the Release Explorer, and here we can see the final validation to validate that the deployment to production was successful. Let's go ahead and approve that. Before we finish off this demo, I want to show you one more thing, and that's how we can configure the automated deployment. If I come to Configure Paths, we'll select the Fabricam Fiber Call Center and open up that path. Here's where we can see the various stages and how the approvals work in those stages. We can also set security for those stages and manage that accordingly. And finally, configuring applications is where we specify the workflow for the automated deployment. I'm going to open up the Fabricam Fiber Call Center app. Here we can see a Windows workflow that specifies all the steps necessary to deploy the application for each environment. There's a workflow for dev, for QA, and production. In this case, they're all the same, they just target different virtual directories inside of IIS. Of course, in most situations, there could be other differences between the environments. TF Service now offers the ability to do cloud load testing. Here I've got a solution open with a couple of web tests and a load test. In order to run this on the cloud, I just open up the test settings file and change the location from running on the local computer to running with Visual Studio Team Foundation Service. Once I've set that, the tests will be handed off to TF Service for running. There are a couple of extra settings that I can set, like deployment, setup and cleanup scripts, and some additional settings. I'm going to leave everything as the defaults. Let's run that load test. The graphs that come up while running load tests in TF Service are similar to those on-premise. At the moment there are not as many counter sets available, but we can still get statistics nonetheless. The run is completed. At this point we can analyze the graphs by clicking Download Report. If we click View Report, it'll open it up for us as if we'd been running this in an on-premise load testing rig. We can also manage our cloud test runs by going to the Load Test and clicking Load Test Manager. I'm going to change the filter to display a previous run that I had. We'd be able to download the results from any runs and do any comparison reports, just like the on-premise load testing. Of course, since the agents are running in the cloud, you'll need a public-facing website for them to hit. If you have MSDN with Visual Studio Ultimate, you'll also be entitled to some free load testing every month. This now means that you can do full load testing without having to set up your own load testing rig. The cloud load testing also works on a pay-as-you-use model, so you can use it just when necessary. Visual Studio 2013 and Windows 8.1 now support coded UI testing for Windows Store XAML applications. Here I have a simple calculator application that's written in XAML, and I'm going to create a new project to do some coded UI testing. I'll right-click the solution, select Add, New Project, and under C# Windows Store, I'll see the coded UI test project template. We'll call this bingcalc.codedui. Visual Studio then asks me whether I'm going to edit the UI map or manually edit the test. Notice there's no support currently for recording actions. I'm just going to select manually edit the test. Let's go and rename this class from coded UI test 1 to bingcalc tests. And that'll rename the class as well. We'll also rename this coded UI test method 1 to test calc can add. Now we can add the code we need to launch the application, do some tests, and eventually close the application. To launch the application, we can use XAML window.launch. I'm going to right-click, select Generate Code for Coded UI Test, and use the Coded UI Test Builder. That'll minimize Visual Studio and launch the Visual Studio Coded UI Test Builder. I'm going to use the Target button and start dragging over the tiles on my desktop until I find the bingcalc tile. I'm going to let go, and the Coded UI Test Framework is going to figure out the properties for that particular tile. I'm interested in this automation ID, so I'm going to right-click and select Copy Value to Clipboard to get the automation ID for this application. Let's close the Coded UI Test Builder, which will bring us back into Visual Studio. Let's make a variable called app_id and hit paste to paste the value of the automation ID. We can now get a variable called calc, and we're going to use XAML window.launch, which is a static method, and this method takes in a string called app package family name, which is the automation ID we just captured. So we'll supply that app ID. Eventually we're going to close this window, so we can call calc.close in order to close that application. At this point we're ready to actually start interacting with the UI. We can do this using the keyboard or mouse namespaces that have been in coded UI testing since coded UI testing came out. Visual Studio 2013 now adds a new namespace called gesture, which has support for various gestures in Windows 8. Let's use gesture.tap. We'll first need to get the properties of a button so that we can actually tap it. I'm going to right click, select Generate Code for Coded UI Test, use Coded UI Test Builder. Let's launch the Bing calculator. I'm going to grab my target and put it over the For button. The Coded UI test framework inspects the properties of that control. I'm going to expand the flyout here. Let's rename this control. Let's just call this button 4. I'll then click the Add Control to UI Control Map button. And finally, we'll click Generate Code. Even though we haven't generated a recording or a method, we can still generate the coded UI map. Let's close the recorder. You'll see now that Visual Studio has added the UIMap.UI test file. Double-clicking on that will open up the control map and the UI actions. If I expand the UI map, I'll be able to browse down the hierarchy to button 4. Let's now go back to our tests and add a gesture.tap. And then we'll walk down the control hierarchy to tap button 4. Let's look at the button 4 method. The button 4 method does a search on the buttons where the XAML button property names.name is equal to the text 4. We can use this to extrapolate our own search method without having to record additional buttons into the UI map. I'm going to expand the UIMap.UI test, double-click UIMap.cs, which is a partial class of UIMap where we can add customizations. Let's add a public void method called tapButton, which is going to take in a string called button text. We'll instantiate a button, which is going to be a new XAML button. I'll just resolve the namespace for the XAML button. When we instantiate the XAML button, we can give it a parent. Since we already have the parent, we can use that. The parent is the UI Bing calc window. Now let's copy the search properties from the generated code. We'll then set the search properties and set the name equal to the button text. Finally, we'll call gesture.tap to tap the button that we've searched. Let's go back to our test. We can now call this method directly. Let's tap a few more buttons. We'll tap the plus button, then we'll tap the 5 button, then we'll tap the equals button. At this point, we want the calculator to display a 9. So let's add a step to validate the display. I'm going to right click, select Generate Code for Coded UI Test and use Coded UI Test Builder. Let's again launch the calculator application. I'm going to grab the target and drag it over the text box. I'm going to scroll down in the text box to the text property and click Add Assertion. Here we were able to choose various comparators. We'll just leave it as R equal and we'll default it to 9 since that's the result that we want from our first calculation. We can type a message for the assertion failure. I'll just type wrong result and hit OK. Let's go and generate that method. We'll call this validate result. And we'll click add and generate. Let's close the Coded UI Test Builder to go back into Visual Studio. The recording has added a validate result method that we've just recorded. Let's go and extend this validate result to make sure that it's a little bit more extensible. Again, I'll open up the UIMap.cs class and we'll create a public void validate result that takes in an integer of the result we're expecting. We're going to call validate result, but before we call that, we're going to override the default. Every validation method gets an expected values property, which lets us override the values that are defaulted on the validation. This time it's UI item edit text, which we're going to override with the expected toString. Let's go and fix our test to use this new method. We now have all the code we need to launch the application, press some buttons and validate a result. I'm going to open up the Test Explorer window so that we can run this test. Let's change our grouping to group by class. Here we can see the Bing Calc tests. The other tests are unit tests in another project. I'm going to right-click Test Calc and Add and select Run Selected Test. That'll launch the coded UI test locally. The test is completed successfully. Let's copy and paste this method to create a subtract test. It would be as easy as changing the name of the method, test calc and subtract, and changing some of the buttons. So we'll tap 7 minus 3 and validate that the result comes to 4. Let's run that test now. Both our tests are succeeding. I'm going to check this in to source control so that I can run this as part of an automated build, deploy, test workflow. I'll enter the comment added coded UI tests and hit check in. Let's go ahead and queue the build to build our application. I'm going to go to the home page of the Team Explorer, click on Builds, and queue the Bing Calc code build. That'll build our application. Now that we've checked in our code, we can associate that automation with tests. I'm going to open up the web access page where I've gone to the test hub. Here I have in my Windows 8 testing plan a suite called automated tests. Let's create 2 new test cases as placeholders for the automated tests. I'll call this test calc can add, and we'll save and close. And we'll add a new one called test calc can subtract, and we'll also save and close. Let's take note of those IDs, 249 and 250. Let's go back to Visual Studio and associate our coded UI tests with these test cases. Let's search for work item 249. I'll click Associated Automation and click the ellipsis button to select the test. Here I'll click Test Calc and Add. We'll save that. This automates the test case. I'll repeat the process for test case 250 for the subtract case. We can see that our code build has completed successfully. Let's go and edit our lab build so that it can run those automated tests. I'll right click my Bing Calc lab build and edit the build definition. Under process, you can see I've used the lab default template which is configured by a wizard. I'm going to open up the wizard. I've selected my environment, Windows 8 Lab. I've selected the build. We're going to grab the latest code from the Bing Calc code build. Any deployment which needs to occur can be configured here. And finally, with test, I've specified that we're going to run the Windows 8 testing plan and the automated test suite. We can now queue up the lab build. The lab build completed successfully. If we want to see the results, we can click View Test Results to open up the results in the Microsoft Test Manager. That'll give us a detail of which tests have been run and what the results were. We'd also see any diagnostic data that was collected as part of the automation test run. TFS 2013 allows us to add comments to change sets from the web access. I've opened up web access and clicked Code to go to the Code Explorer. I'm going to click History to open up the change sets. Let's select this top change set by Brian. On the left hand side, if I click Comments, I can see that there's a comment over here. I'm going to click the comment so that it can open up. Here on the right hand side, I can see that Adam's made a comment. This is a file level comment. Adam can also make line level comments by simply highlighting the portion of line he wants to comment and selecting the comment on selected text. Control Enter will save that comment. The comment is also added to the list of comments for this particular change set. Thank you so much for attending today's webcast. I'll now hand over to Becky, who will tell you some more about our upcoming events and special offers.
Thank you, Colin. Would you like to know more? Imaginet offers a variety of free webcasts and events. To see a listing of or to register for any of our free webcast or roadshows coming up soon, you can visit our website at www.imaginet.com/events. Our next round of webcast topics include new topics such as top business benefits of application lifecycle management, what's new for ALM with Team Foundation Server in Visual Studio 2013, enterprise agile management with TFS 2013, improved developer productivity, managing test labs without the headache, and coded UI testing with Visual Studio 2013. Imaginet is also offering 2 upcoming training classes in 2013. The first is an accredited core Kanban using Team Foundation Server 3-day class. This will take place November 13th through 15th in Dallas, Texas. The second class is a professional Scrum Developer 5-day class. This will take place December 2nd through the 6th in Stuttgart, Germany. Registration links will be included in our follow-up emails later today if you're interested in registering for either one of these upcoming classes. If you enjoyed today's webcast and are interested in adopting Team Foundation 2013, Imaginet can help. We have our TFS 15-day adoption quick start. This includes designing, installing, and configuring your Team Foundation Server and the Visual Studio development tools. Imaginet will teach you and your team the best practices for source control, build and release management, agile methodologies, and work management processes. It also includes support and training for your team and includes a high-level ALM assessment. If you're interested, just email us at info@imaginet.com. Similarly, if you already own Team Foundation Server and are interested in upgrading to the newest version, Imaginet offers our TFS 2013 15-day upgrade quick start. This includes planning and upgrading your existing Team Foundation Server to the newest version. We also covered the new best practices that exist in TFS 2013 around source control, build, agile methodologies, and the work item tracking processes. In addition, you will get support and training so your team is familiar with how to use the new features of TFS, and also includes a high-level ALM assessment. In addition to these two offers, Imaginet also offers a wide variety of ALM planning and implementation services. This includes other upgrade services, remote support, quick starts around lab management, manual testing, automated testing, and load testing, and also integration services that allow you to integrate Team Foundation Server with other products and tools. Finally, visit our Imaginet Visual Studio website. It's really your one-stop hub for all of your Visual Studio needs. Just visit visualstudio.imaginet.com. You'll be able to find all of our consulting services, training services, roadshows, and webcasts in one place. For any other questions or for more information, please feel free to contact us at info@imaginet.com or by calling 972-607-4830. Thanks again, and we hope to see you on another Imaginet webcast.